Hey guys, welcome to lesson 2 from trigonometry entitled Special Right Angles. This one's an important one, and I know from when I first started teaching this course, I talked to Mrs. Bowen, and she insists that her students memorize these special right triangles, so you would have had to memorize them for a quiz. So I'm just giving you a heads up in case you plan on taking Pre-Calc 30 next year. So I always try to make things as easy as possible, but to be honest with you, it doesn't always work. So this is kind of one of those ones where, without you being here, I'm not sure how it's going to go. We're also going to go back to radicals a little bit here. So there's a couple of special right triangles. And remember what I said yesterday, there's just going to be some pieces of things before we finally put it all together. So this is a 45, 45, 90. And it's a special right triangle, of course. We have two equal angles, which means because these angles are equal, we also have two equal sides, and that makes it an isosceles triangle. So angles B and C measure 45 degrees. Now, the relationship between the two sides, the lengths of the two sides here, right? These are the sides, they're equal. And so I'm going to call that a 1-to-1 ratio, right? Because whatever this one is, this one has to be, and whatever this one is, this one has to be. So what we want now is we want to be able to calculate the length of the hypotenuse in exact form. Exact is another way of saying radical form, where we don't round. So what we'll do is we'll take a look at, we're going to say this is 1-to-1. So we're going to go 1 squared plus 1 squared equals a squared. And so 1 squared plus 1 squared is 2. And then we'll take the square root of both sides. And a is the square root of 2. So the relationship between the length of the side and the hypotenuse is root 2 times the length of the side. So just bear with me here while I do that. So what we're going to do is I'm going to give you different measures for these, and you're going to have to calculate the other ones. And I'll show you that here as soon as we talk about the other one. And the other special right triangle is a 30, 60, 90. And it can look obviously like this. It can be rotated, all kinds of things. So I've given you two sides. This is the short side. This is the hypotenuse, and this is the long side. So the relationship between the length of the short side and the length of the hypotenuse. So I've given you two measurements just to help you out. So if the short side is 10 and the hypotenuse is 20, the hypotenuse is twice the length of the short side. So now what we want to do is we want to figure out what the long side is, and so we're going to have to use the Pythagorean theorem again. I'm going to call that x. X squared plus 10 squared. So 400 minus 100 is 300. And so this one can be simplified into root 100 times root 3. So 10 root 3. This one might be a little bit tricky, but I'm just going to see. So the relationship between the short side and the long side it's root 3 times the length of the shortest side. So I'm not going to spend too much time on this, but this is what it looks like, right? So we've kind of discussed this already. So 45, 45, 90 is 1-to-1 to root 2. That one's easy to remember, right? So side to side, and the reason I'm going to do this with you is because this is how I found it was the easiest to teach students how to calculate it. So side to side, 1-to-1, right? Discussed that already. Side to hypotenuse is 1 to root 2. and that's because these are equal, and this is root 2 times. The other one, now this one you can see I've set it up a little bit differently already. I've just flipped it, right? So when it comes to the short side and the hypotenuse is twice the length, so it's 1 to 2. And the long side is root 3, so long side to short side. And long side to hypotenuse is root 3 to 2. So hopefully that went well. So now here's the fun part. So leave your answers in simplified exact, which means radical form, so it means we don't simplify. And you're going to see rationalizing the denominator, which goes way, way back to when I taught you, before the February break. Wait. No, I don't even know if I taught you this. It was probably after the February break. So given triangle ABC, calculate the measures of B and C. And so what it says in your instructions, and I just found that this worked the best, is we set it up in proportion. So this is our 30, right? Shoot, sorry. It's not the 30, that's the 60. I don't have an eraser that works very well. There we go. Okay, let's just try that again. So 30, 60. So what I recommend doing if you're having a hard time with this is put the numbers on there, right? The 1 to 2 to root 3. So short side is 1, hypotenuse is 2, and long side is root 3. So if I was giving students individual help, that's what I would say, because I think it makes it a lot easier. And as you get working with it and, you know, get more experience, I don't think you'll need to do that anymore. So what we want to do is we want to calculate both, so it doesn't really matter. We'll just start with, we won't deal with the radicals right away, right? So if we want to do this one. So here's the way that I set it up. There's lots of ways to set it up. Just make sure, well, I'll explain it when I'm done. So 1 to 2. Okay, so that's the ratio between the sides. Now our real sides are 8 and C. So you can see I have, this is the numbers that were given for basic 30, 60, 90, and these are the ones on the triangle. Okay, you just have to watch that you don't get them diagonally, you'll be in trouble. And then we just cross multiply. So 1 times C is C. Okay, and I totally understand that looking at that, like, well, if it's just double, you just times it by 2. Bear with me, because when you're going the other way, it gets a little tricky. So now we'll look at this one. So we want B. So this time we're going to go 1 to root 3 equals 8 over B, and we'll multiply again. And remember when we're multiplying radicals, right? It's just like multiplying 2 times x. We put them together, we get 2x. Okay, hopefully that was a good one with an introductory one. Given triangle ABC, calculate the measures of A and B. And so we'll start with A. This is another 30, 60, 90. So short one is 1, height is 2, and this is 3. And so we'll calculate A first. And so we'll go 1 to 2 is the same as this. So we'll get 2A equals 20. And that we could have seen, right? Because we know it'll be half the hypotenuse. Okay, so now what we'll do is we'll go, and you can, there's lots of different, well, I shouldn't say lots of different ways, but there's not always only one way to do it. So the way that I'm going to set it up is I'm going to use these two, because I know that the 20 is right, just in case I made a mistake. So I'm going to go 2 to root 3 equals 20 over B. So then I'm going to do my cross multiplication. 2B equals 20 root 3, divide both sides by 2. And there we have it. Okay, last but not least, given triangle XYZ, calculate the measures of X and Y. And so we know, because this is a 45, 45, 90, that it's 1 to 1 to root 2. So we're not going to do 2 separate calculations for X and Y. We're going to calculate one of them, and we're going to say that Y is the same thing, right? So now we're going to go 1 to root 2 equals, we'll do x to 2 root 5. Here's where it gets a little bit interesting, right? So we're going to do cross multiplication. So root 2x equals 2 root 5. We'll divide both sides by root 2, and you know that we can't have a radical in the denominator. So we need to rationalize, goes way back to February, right? X equals 2 root 10 over 2, right? Because that's a square root of 4. And divide both sides. 2 divided by 2 is, so then that's that. And that's that as well. So there's kind of an example where I think really the ratios come in handy. And this is another one that I'm going to sneak in here. It says complete the table without using a calculator. Leave answers in a simplified exact form. So this now is going to go back to SOHCAHTOA. And we're actually going to change SOHCAHTOA. We're going to change the letters of that one. I hope that's not too disappointing for you. So we're going to go to sine of theta for 30 degrees, right? So sine is opposite, right? Opposite over hypotenuse. And so that's 1/2. I don't know if it really matters. So I think I'll just go across with the 30s. I think that'll be easier, and I'll just stay here. So cosine is adjacent over hypotenuse. So adjacent, the side next to, right? Adjacent over hypotenuse. And tangent is opposite over adjacent. So, and then 1 over root 3. And instead of showing you the whole multiplying by root 3 over root 3, by all means, we can take a shortcut. And so that's what we're looking for there. 45 degrees will go up here, right? So sine is opposite over hypotenuse. So that's 1 over root 2. And when we rationalize the denominator, we're going to get cosine, because we have 2 identical sides, we're going to have that. Tangent is opposite over adjacent, and then we're going to get a 1. And last but not least, so here for 60, we're going to go opposite over hypotenuse, and then we're going to go adjacent over hypotenuse, and then we're going to go opposite over adjacent. So root 3 over 2, 1/2, and root 3, and we're all finished.